So we are going to work on approximating area under the curve, and they actually gave us the graph of what we're looking at for left endpoint rectangles, but I just want to talk about how we come up with those rectangles. So first thing you want to look at is, of course, what the equation is, graph it, and just a sketch is honestly okay because the values you don't need from the graph, you can just use the equation to find the y values, or I'll show you how to use the table setting on your calculator to find them really quickly. Of course, you won't always have a calculator, but if you do, then you can use your graphing calculator to find values. So you have the equation, and then we are going from -3 to 3, so that's our interval. Now we're using 6 left endpoint rectangles. So the way that we find the width of each rectangle, which I'm going to call delta x, is going to be the total width of the interval. So from -3 to 3, that's a width of 6. And then we're dividing that, so this is the interval length is 6, and we're dividing that by 6 because that's the number of rectangles. And so delta x is equal to 1, which means I am going to have a rectangle every 1 unit. So we are starting simple with, just widths of 1, but these will eventually get more complicated with widths of a half or widths of 2 or widths of 2/3. All right, so we have widths of 1, and then because we have left endpoint rectangles, we're going to start on the left and we go all the way up from the x-axis. So we are always bounded by the x-axis. So we start on the x-axis and then we go to our function starting on the very left-hand side. And then once you find that point, you're going to make a rectangle. And then I go to my next point, -2, and I go all the way up from the x-axis to the function, and then I create my next rectangle. And then I go from -1 and I go up to my function. There's my next rectangle. And then 1, 2. And then notice that at 3, we stop. First of all, we already have our 6 rectangles. 1, 2, 3, 4, 5, 6. We already have 6 of them. But also, if I were to go up at 3, which is the most right-hand point, if I were to create a rectangle there, now I'm outside of the interval. Now I'm ending at 4. So any way you want to think about it, you're stopping with your rectangle at 3. We are not going to use our most right point. Okay, and then we just need to add up the areas of all these rectangles. Well, rectangles are just width times height, right? Or base times height. Well, all of these have the same width. They all have widths of 1. So instead of doing like 1 times my first height, plus my next rectangle, 1 times my next height, plus 1 times my next height. If all the widths are the same, because they're all 1, then we don't need to add them all up separately. We can factor out the width and then just add up the heights. So I'll call that h sub 1, h sub 2, h sub 3, h sub 4, h sub 5, and h sub 6. So I just add up all the heights and then multiply by the width on the outside. And that just saves us a little bit of time. Okay, so how do I find the heights? Well, from the picture, I can estimate. I can also just plug in the values themselves, right? So I could plug in, we have a point at -3, and then I plug in -3 into my function. I get 18 plus 1, which is 19. And then I plug in -2, and I plug in -1. And again, I'm plugging in all the numbers. I am not plugging in +3. I'm only plugging in from -3 to 2. I'm not actually plugging in -3 because I don't have a point at, +3. I don't have a point at +3, so I'm not going to plug that number in. I should be plugging in a total of 6 x values to get 6 heights. So that is how we can do it without a graphing calculator, is to simply plug the numbers in. Now, suppose that I have a graphing calculator. So you can see my little graphing calculator here. And what I can do is I can plug in my function 2x squared plus 1. So I have my function. I could graph it so I can see the graph. But what I want to do is be able to find the values quickly. So if I press second table, I can see my table of values. And now I'm starting at 0, but I actually need the values starting at -3, So I can either go up, but let's say that we wanted to have the halves as well. So this is not this problem, but let's say I had 12 left endpoint rectangles, and that would mean each width would be a half. So I would need -3 and -2.5 and -2 and -1.5. So what if I also wanted like even more values here? So to change your table settings, go to second table set, TBLSET, and we're going to start at -3. And then instead of increasing by ones, let's say we want to increase by 0.5. And then I go back to second table, and now you can see even more values. Now I'm increasing by 0.5 each time. So this will work well if you have any sort of, even if you were increasing by 2/3. Like let's say the width of each rectangle was 2/3. I could go to second table set, start at -3, and then my table, I'm going to say 2/3. And then I go to second table, and now I'm increasing by 2/3 each time. And notice that I didn't even have to enter in like 0.333 or 0.667. Like it does that work for me by just entering 2 divided by 3. And then this gives me all the values for y. Now I will point out in this class, and I will say this a lot, you have to use at least 3 decimal places as you go. So if you had all these ugly decimal places, you would want to use all the decimal places they give you. So we don't round in this class. But again, I'm just increasing by ones for this particular problem. So I go from -3. I'm going to increase by ones each time. Second table. And now I have my table of values again. So I have 19, 9, 3, 1, 3, 9. So those are my values from -3 to 2. So 19, 9, 3. Let me go back to my notebook. There we go. So my first height was 19. My next height was 9, 3, 1, 3, 9. All right, and then I just add those up and multiply by my width, which is just 1. So I get 19 plus 9, which is 28, plus 4 is 32, plus 12 is 44 units squared. And that is my answer for my left endpoint rectangles. Okay, so let's do right endpoint rectangles. So right endpoint rectangles, I'm still going from -3 to 3. I still have 6 of them, so the widths are still 1. But now I'm not going to start on the left side. I'm going to start on the right side. So I start at 3, and I go up, create my rectangle. Go to at 2, go up, create my rectangle. 1, 0, -1, and -2. And this time I'm not plugging in -3 because that's not on the left hand. I'm sorry. If I were to plug in -3, I'd have this rectangle, which is outside my interval. And you can see I already have my 6 rectangles. So start on the right side and go all the way up from the x-axis to the function. That's your first point. And then create your rectangle, and then head to the left over that interval. So remember, area under the curve is always bounded by the x-axis. All right, and then this time, my width is still 1, so that's going to be 1 times adding up my height. So this time my height is, I'm going to just start on the right. So this height was 19, this was 9, so 19 plus 9 plus 3 plus 1 plus 3 plus 9. So I have all my heights here. I'm just labeling the heights. I'm not labeling the coordinate values. But again, you would just use your graphing calculator to find the y values at each of these points, or plug in the values. So if I plug in -2 into my function, -2 squared is 4. 4 times 2 is 8, plus 1 is 9. All right, and then I add all these up, and again, I get 44 units squared. Then I am going to do trapezoid. So trapezoid, -3 to 3, I still have widths of 1, but trapezoids are different because now I use the left and the right hand side. So I'm going to go up from the left and then from -2, and that, when I connect them with a straight line, is my first trapezoid. And then from -2, I already have that point, and then I go up from -1, connect those 2 points, and you'll notice that a trapezoid is a way better, the lines are way closer to the actual heights of my parabola. So what I mean by that is like these lines here match the parabola's shape much better than these do. So you can see like here, when I use a right rectangle, I've got extra space here, and then I've got like missing space here. And so it's not as good necessarily of a representation of the area under the curve. Trapezoid is a lot closer to the curve, so it looks to be a better representation of what the area actually is. So trapezoids, we can start on the left or the right. It actually doesn't matter because you will be plugging in both -3 and 3. So my first trapezoid has a width of 1, and then I average the height. So my first height was 19, and my next height was 9. So I'm saying this is trapezoid 1. This is trapezoid 2, et cetera, et cetera. So trapezoid 1, just want to label these for you so you can see what my work is. My first height was 19, my second height was 9, and I'm doing an average of them. And then I'm going to add trapezoid 2. So that was a height of 9 and a height of 3. Oh, and a width of 1. So width of 1, and then I average my heights. My third trapezoid has a width of 1, and then I average my heights. Okay. And then you should be able to fill that out yourself or finish this yourself. And then you get T4, T5, and T6. So T4 is going to be 1 times 1 plus 3 over 2. T5, 3 plus 9 over 2. And T6, 9 plus 19 over 2. And again, you'll notice that I did use both endpoints once. So my first endpoint I used here, and then my last endpoint I used here. And when I add all of these up, oh my goodness, I get 44 units squared again. So the question is, will that always happen? Will the left endpoint and the right endpoints in the trapezoid always be the same? No, they will not. As you can see from the shapes, they create very different shapes here. Okay, like here I had area over, area over, area over. I had this area under, so I had missing area, I had area that was over. And the only reason that I ended up with kind of like the same answers each time is because I have from -3 to 3, and it's a symmetrical graph. So I want to point out that this is not going to happen every single time where all of these answers are the same. I don't want you to just find the left endpoint rectangles and say, oh, the right endpoints will be the same, or oh, the trapezoids will be the same. That's just kind of a coincidence here. Most of the time, they will be different answers, so you should be able to come up with them all separately.